Welcome to Van Gelder Tutoring. Today we're looking at relative mass part 2, which covers relative atomic mass using data from mass spectra. So what is a mass spectra? A mass spectra is produced by a piece of equipment named a spectrometer. Now, a spectrometer is an instrument which can analyze the components of a sample and determine their mass. So the mass spectra of chlorine is shown to the left here. We know that chlorine has two isotopes, chlorine-35 and chlorine-37, and we can see that we can also see abundance on the y-axis. We can calculate relative atomic mass of chlorine using the data shown the same way we did previously, only this time, rather than being told the relative abundance, we have to determine them ourselves from the data presented. We can see chlorine-37 has a percentage abundance of 24.5, while chlorine-35 has a percentage abundance of 75.5. Once we extract this data from the information shown, we can use the equation that we covered in our previous lesson to calculate the relative atomic mass. Mass spectra can display percentage abundance, which is what we are so far familiar with working with, or alternatively relative abundance. If relative abundance is shown rather than percentage abundance, the formula we use is slightly different. We still use the masses of the isotope, so for example mass of isotope 1 and mass of isotope 2. Only this time, rather than multiplying by the percentage abundance, we simply multiply by the relative abundance. So in this example, we would take the mass of isotope 1 and multiply it by the relative abundance of isotope 1. Whereas for isotope 2, we'd take the relative abundance of isotope 2 and multiply it by the mass of isotope 2. So that's quite straightforward. Only this time, rather than dividing by 100, we add together the relative abundances. So in this case, we'd add together relative abundance 1 to relative abundance 2, and this is what we would divide by. Now, of course, there's no reason we have to stop at 2 isotopes, and in some cases you might have 3 or 4 different isotopes that you want to calculate a relative atomic mass for. When you do this, you simply add in some extra parts to the equation, and the equation still functions in the same way. Let's try a worked example. So this question is calculate the relative atomic mass of neon from the data provided in the mass spectra. The first thing we're going to need to do is determine the mass and the abundance of each isotope of neon. So to start with, let's start with that most left-hand side peak. We can see that the left-hand side peak has a mass of 20 and an abundance of 1181.96. So we can start by popping those into the table. Now let's move on to the next peak. This is a very small peak and easily missed, but is there nonetheless. This one has a mass of 21 and a relative abundance of 3.38. So again, we can fill this into the table. And then last but not least, at a mass of 22 with a relative abundance of 114.66. Once we have all that data, we can start constructing our equation. Now this is the equation that I showed on the previous slide, if you wanted to pause and have a go here at constructing the equation yourself. So to start off with, we're now going to take the relative abundance and relative mass of isotope 1, which in this case is 20, multiplied by 1181.69. We can then add in isotope 2, which in this case has a mass of 21 and an abundance of 3.38. And then finally, isotope number 3, which has a mass of 22 and a relative abundance of 114.66. Next, we need to add in our division. So to do that, we're going to add up all of the abundances together. So 1181.96, 3.38, and 114.66. Punch that into a calculator, and the result we'll get is 20.17. Of course, in chemistry, we stick to working with 3 significant figures, which means that this number would round up to 20.2. Thank you for watching Van Gelder Tutoring. This has been Relative Masses Part 2. I hope you have enjoyed. If you wish to support the channel and support me in making more videos, please drop the video a like and subscribe to my channel.